Hi, it's me, Tim Dodd, the Everyday Astronaut. I just finished up a conversation with Rocket Lab's founder, CEO, and CTO, Peter Beck. It's an awesome conversation, so here you go. Peter, how's it going?
Good, thanks, Tim.
Well, you guys have been awfully busy since I spoke with you. It was almost a year ago, and right off the bat, you came out and you are now someone that has eaten a hat.
Yeah.
Can you?
Yeah. Technically, it was two hats because it took us a lot of takes, but yes. Yeah.
That video, honestly, so for those of you that haven't seen it, I'll probably put it up on screen right now, but Rocket Lab and Peter Beck, they just came out with this incredible, absolutely gorgeous video, a beautiful, well-produced video about your upcoming rocket, the Neutron. So, Why don't you give me your elevator pitch and the overview of Neutron, what it is, and why you're building it?
Yeah, well, I mean, so, I wanted to get all of the things that we said that we'd never do out in one event, so I didn't have to eat multiple hats. So that was kind of the justification for talking about everything there. And yeah, look, there's a tremendous amount of kind of changes within Rocket Lab. Generally, as you know, Tim, we don't talk about things until they're well and truly down the path or even done. Like surprise, we've put a satellite in orbit. Sort of thing, but as we transition to become a public company, that kind of doesn't work anymore. So we had to kind of make a bunch of announcements. One was obviously we were going public as a company, and then the other programs that we had underway within the back of the company. And one of those is a larger launch vehicle called Neutron, and it really. The Electron is a wonderful platform and continues to be a wonderful platform for flying. Many of our customers, and quite often will fly the first of in a constellation, or the first of in a kind of a spectrum test or equivalent. And it's great for getting those first offs up there, but customers were coming back to us and saying, okay, Pete, now we've got a couple of hundred of these. Can you get those on orbit for us? And so it became more and more obvious that a larger launch vehicle would be required. And as we started looking into it, the trick here is really settling on the right size. And I think we did that well with Electron, is really defining what we thought the optimum small launch vehicle was, and it's proven to be very successful in flying just about everything that comes on our doorstep. And the same was important for Neutron, is really where is the market niche. And we did two things. We looked back in history and we said, okay, what's the average payload lift mass? And if you sum up all the payloads lifted, almost in the history of spaceflight, you come out with between 4 and 5 tons. And then if you look at the most prolifically flown launch vehicle, the Soyuz, it's kind of 4 to 5 tons, but an 8-ton class launch vehicle. And then if you project forward with all of the constellations that are being proposed and a bunch of other missions, you kind of end up in the same place once again. So, that kind of really honed us in on building a vehicle in an 8-ton class, because between that and Electron, you can consume the majority of all the launch that's required. And if you're building an 8-ton class launch vehicle, then it would be kind of rude not to make sure that you could, put a few people on the top. So if you're going to develop a vehicle from scratch, you may as well develop it with the intention of being able to do human spaceflight, because the one thing I've learned is never say never. And I don't want to go back and completely requalify and completely redesign a launch vehicle at a later date for, that's capable of human spaceflight. So and there you have it. Kind of what popped out of all of that work was Neutron, an 8-ton vehicle, fully reusable first stage, and there'll be a little bit more announcements here in the coming weeks about actually that reusability. And I would say that our Electron reusability program has really been invaluable in informing us all of the kind of the pain of reentry and the pain of reusability. So I wouldn't have liked to go into Neutron without having that experience under our belt, because I think a lot of the decisions and a lot of the assumptions would be very, very different.
Yeah, so we'll get back into the Electron's reusability and some of the stuff you guys are working on there, because that's obviously still incredibly exciting. But now, the big thing that kind of surprised me with Neutron is obviously now with a larger launch vehicle, you're finding margins to be able to do propulsive landing. So are you, okay, so I guess I don't even know, is this still going to be a carbon composite body vehicle like Electron, or are you guys looking for another material? I forget.
Yeah, no. So we have a different material selection from Electron, and once again that'll be part of when we give a bit of a Neutron update. But yeah, I mean, with small launch vehicles, you just don't have the margins to do any kind of propulsive landing. Larger launch vehicles are, much more attractive to do that kind of return to base approach.
But one of the things that is most impressive with the way you've proven to survive the wall with Electron is being able to survive reentry without any propulsive slowdown at all. You're just gritting your
coming
teeth
in hot.
and getting just coming in hot. So is that something that you're hoping to be able to do with Neutron as well? Now that you've kind of learned the tricks of the trade there, or will Neutron require?
Yeah, absolutely. I mean, the
advantage.
advantage with Neutron, right, is having all of that knowledge, and it really is starting from a clean piece of paper and saying, okay, let's make the most reusable first stage in history, and how do we apply all the lessons we've learned, and then the second stage is quite unique because the second stage needs to be a very high performance, but also a very low cost, upper stage, which generally they're at the opposite ends of the spectrum to each other. But I would say yes, definitely the lessons learned from Electron are being directly applied to Neutron from a re-entry standpoint. And Electron was always never intended to be a reusable launch vehicle, so we're kind of turning it into one. Whereas this is an incredibly luxurious scenario to sit there with a blank piece of paper and say, well, here's all the things we've learned about flying Electron. Here's all the things we've learned about reusability and re-entering. How do we make sure that this isn't just a refurbishable vehicle, but a vehicle that actually literally you just roll back out and go again?
So I had to push back on that real quick. I guess I maybe never realized that Electron, like I maybe have heard you say that Electron was never meant to be reusable, but I always thought like, oh, maybe that's just kind of you holding back, but you genuinely did not plan for reusability with Electron when you were first designing it?
No, that's why I had to eat a hat. I mean, so it was always an intention to make the most manufacturable launch vehicle possible, and we did a really great job at that. But even then, there's nothing better than not having to build a rocket than not having to build a rocket. So I think if we had set out to make Electron a reusable vehicle, it would be a different architecture. There's a whole bunch of set assumptions and constraints you have to make when you have a small launch vehicle anyway. So yeah. So
propulsive landing. I know you guys are going to be using RP1 and liquid oxygen again. So the same fuels. I assume on both stages for Neutron. Is that correct? Still?
Yeah. I mean, there's places we're looking to innovate and places we're not. Neutron is not about extracting the last second of ISP out of an engine. It's about making sure it's the most robust, reliable platform. Something that you can bump into and not worry about, some having to go back and do a whole lot of NDT for damage inspection. Like it's literally, trying to build the airliner of the space industry where, it truly is, a serviceable vehicle rather than, land it and do a whole bunch of work to it before you can fly it again. So all of those things are, are very tightly constrained requirements for us.
Have you announced the how far are you into the new engine for that vehicle? Are you far enough to know what cycle type it is? Is it still going to be 3D printed manufacturing? I know the number of engines may even currently be in flux, but why don't you run me through as much as you can about that, specifically the cycle type? I'm curious if you're sticking with the electric pump fed cycle.
I think you've just about said as much as I would be able to say there, Tim. So you've covered it all off perfectly. No, I mean engines are one of those things that are kind of personalities of their own. So I would be a great disservice to not give it the level of disclosure at the right time in a proper kind of dissertation. But what I will say is there's areas that we're looking to innovate and areas where we're not. And propulsion is not, as I mentioned before, we're not looking to extract the last ISP. What we're looking for here is an engine that is really good survivability on re-entry, very, very reliable and very large inspection times, between running. And I would say that all of our experiences have informed us on these kinds of things. I mean, the electric turbopump cycle is a wonderful cycle if you just want to start an engine, stop an engine, start an engine, stop an engine, and do nothing in between. There is no pre-burners, there's no T-tab, there's nothing. It's all torch ignition, and it's just literally take a Rutherford, and light it up, purge it with hot nitrogen, and light it up again. There's a lot of components on that engine which we've yet to even determine a life, because we just keep on taking them out and testing and testing and testing. So that kind of ethos and mentality is pushed across to the Neutron propulsion system, and of course a lot of the technologies, we've put 190 3D printed engines in orbit now, or in space. We understand that technology very, very well, and so we'll take a lot of learnings and a lot of experience, obviously, as we move forward. But if you're expecting some super crazy engine cycle with some, extracting the last kind of 0.2 of a second of ISP from this propulsion system, you'll be disappointed.
And still no aerospikes.
No aerospikes. No.
I knew the answer to that before I said it. Now,
maybe we should put it in trade, though. Maybe we should put that in trade. Yeah, never know.
Yeah, I mean, come on. You don't want to eat another hat, so just in case.
Yeah.
Just in case. There was actually really cool, a really interesting concept for an aerospike. This is just nerd talk here. We're going totally off script. It was called I think it's called the Dean, and it's an expander, a dual expander cycle aerospike. So it sort of takes the pros or the cons of each system. Too much heat on an aerospike, and then for an expander cycle, you need actually a lot of heat to be able to spin your pumps. Yeah. It kind of takes those two weaknesses and melds them together. I thought that was a very interesting concept. So just in case you're looking at trades,
I do love an expander cycle. I love an expander cycle, but you're right. You always end up having to do expander bleeds or something like that to try and get enough energy. So I am a sucker for an expander cycle.
Just maybe do me a favor and look up the Dean, the dual expander cycle aerospike engine.
Yep. Yeah, it makes perfect
just
sense.
Just for fun.
Yep.
It's cool because I like that it kind of exploits both of their weaknesses to make a strength. So yeah. So the other thing that the internet was kind of going nuts over, and I'm sure this is just because it was a simple rendering of Neutron, but we couldn't help but notice that there's 4 engines on the render, and you're doing propulsive landing, which would be rather difficult to not only have low enough throttle with so few engines. As we know, the Falcon 9 has 9. They shut off all but one engine, and even at the one engine's minimum throttle, they're still at a pretty high thrust to weight ratio. Yeah. So obviously, the fewer the engines, the lower your number. But also having 4, you'd have to have 2 running to not have asymmetrical thrust. Was that just a render, or is that actually something that you're considering doing?
Yeah, or there could be something in between those 4 engines that you can't see as well, potentially. But this is the challenge, right? Because ultimately for a launch vehicle, in my opinion, now you want the least number of engines possible, because the more number of engines, the more acceptance testing and the more qualification and more of everything, like just more manufacturing. So the least number of engines is always optimal. However, when you're talking exactly as you say, propulsive landing, then you have a particular thrust. And that you require for that maneuver, and that doesn't trade nicely with the small number of engines possible. So both those constraints are kind of polar opposite to each other from what you actually want to achieve. So there's some interesting trades you can make there to try and optimize that problem space. Oh,
just throw Rutherford in the middle there and just use it for landing.
Oh no, I think Rutherford's not enough. It's a bit more than that.
Yeah, you need 9 Rutherfords in the middle probably.
Yeah.
Just throw a whole Electron power pack right in the middle of this thing. No big deal. We'll Kerbal design this thing for you. Don't worry, the internet's gonna figure it all out for you guys. I'm sure.
Yeah.
Jeez. Speaking of Electron now, you guys, it's been over a year. Wait, when was that? No, not over a year. When did you guys recover? That was when you actually you went through the wall in 2019.
Yeah.
And then in 2020 is when you successfully recovered. When are you going to go for recovery again?
So recovery is next flight. So the next vehicle is a recovery mission. So that mission will be similar to the mission we flew in. I think it was December, where we got one back. But with upgraded heat shield and a bunch of other stuff as well.
So in only 4 months, you were able to crank out a new heat shield design, probably a decent amount of stuff that you learned from your other one, Return to Sender. I mean, that's got to be that feels awfully quick. What can you talk about some of the changes that you were actually able to make in that time?
It's never quick enough.
Not spaceflight world, yeah.
Yeah. So, I mean, really, the first one re-entered at the end of last year was, it had no heat shield modifications. And if you understand, our approach here is we're very much using the blunt body of the engines to kind of propagate a shockwave forward and try to ride in the wake of that shockwave to limit the heating. And this is fundamentally a control and heating issue. And that heat shield, we knew it was undersized and undercooked, but there's also a lot of unknowns that we also, didn't know. So instead of kind of obsessively focusing on one element, we thought, well, it could be a ton of stuff that we're going to have to change here. So let's just punch it in and see what we get. And there is nothing like getting back a stage and putting it back in the factory and then cutting it up to understand what you've really got. Just hugely valuable. You can put all the instrumentation you want on it, and we've always been very kind of instrument heavy on our vehicles, but there's just nothing comes close to putting one back in the factory. So this flight is we've really grunted up the heat shield. So we understand what kind of load that last heat shield saw, and that we knew that heat shield would collapse pretty early on into the descent. And of course, once the heat shield collapsed, you've got a whole lot of batteries in behind there that go into thermal runaway, and it all gets a bit ugly down there pretty quick. So the heat shield is really critical in maintaining really good integrity of that whole structure. So. New heat shield design, new materials, and this will be a really important flight for us to see how well that heat shield stands up to it all. There is another iteration on the heat shield as well, so I think that's coming in mid to late 20s tail numbers, where there's another major iteration to the heat shield.
Yep. And now remind me, the engines you would assume would experience a lot of heating, obviously, because they're kind of at the front of that. When you're coming in engine first, it's in front of the heat shield and the dance floor or whatever. Normally, when an engine's running, you're regeneratively cooling them. How do they survive without having, or do you pump fluid through there to actively cool them during reentry, or do you not need to do that?
Yeah, so I mean, on the last mission, the engine bells were the majority of them were in good kind of condition. They are designed to be run, they're Inconel, so they're designed to run very hot. Now, there's a big difference between just getting them back and then getting them back in a condition that you're prepared to fly them again in. So our kind of our approach here with this next flight is to get them back, and then we can assess in a much better way what condition they're really in, and start the recoil program for those. I mean, one of the things that is most time consuming here is actually the recoil of the flight components to be able to certify them for flight again. Because it's a completely different set of environments from launch to ascent. So, on the vehicle, on this recovery vehicle, there is actually the same, it's all the LOX and Kero press system flew on the previous recovery mission. So we're actually stripping components off and off these things, and they were easy components for us to recertify for flight again. So you've got to basically go through that whole stage and recertify everything for a completely different set of load and environmental conditions, and that's actually quite time consuming.
For sure. So for this upcoming mission for your 20th mission here, you're not using the helicopter yet. You're just splashing down again.
Yeah. So we want to get it to the point where we splash down and we've got the stage. We've fished it out of the water in a condition that we think is usable again for another reflight. And then we'll start bringing in the helicopter. At the moment, it's a lot of logistics to bring in there, to try and catch something that it doesn't really matter if it gets wet. That's not, we're not learning anything, worse or better for taking it for a swim.
Right.
So it's just a whole bunch of logistics for just no benefit for the development program right now.
And I figure a helicopter's obviously not free, so you don't want to use it until it's actually time to use it. That absolutely makes sense.
Yeah, and we've done the drop tests, and we're reasonably confident in our ability to catch them. I mean that's not a super tricky element of what we're trying to do, ironically, but actually you're just introducing all of that at this early stage is just not. It just doesn't make sense.
So having kind of torn apart the one that you've recovered and seen inside and everything, how confident are you that this whole thing is going to work out for Electron to be able to actually reuse them? Do you see them being able to be reused over and over? Do you have some kind of any gauge of we might be lucky to get 3 flights out of them or 10, or how are you feeling about it, I guess?
Well, I'm feeling really good. Otherwise, we wouldn't be carrying on.
Yeah.
But I mean, we punched that thing through in the most horrific way possible. So, and not only did it survive, but we're actually reflying components of it on this next mission. And so I think we're all pleasantly surprised with no heat shield improvements, and kind of no kind of TPS improvements or anything like that. That we were able to get it not only back in one piece, but we were able to refly components from it. So I think that gave us a massive boost in the viability of the program for sure.
100%. That says a lot, obviously. So the other thing that I've been kind of surprised and waiting to see is the first launch of Electron at Wallops.
Yeah. Yep.
Do you have any timeline on that?
Well, we're taking one for the team on this one. What we're really gated by here is the development of the AFTS, or the certification, I should say, of the NASA AFTS software. So obviously we fly the AFTS out of New Zealand, but to go into a federal range like Wallops, there has been no AFTS ever flown out of that launch range. So we're not just kind of bringing Electron here. We've had this AFTS collaboration with NASA and DARPA since Flight 1. Even the very first flights had shadow AFTS systems on board. So this has been a really long, collaboration for us. And what we're trying to do here is actually bring an AFTS system to all launch vehicles and all ranges. All of the launch ranges in America, want to be AFTS or autonomous flight termination for years, certified by 2030 or even sooner. There is no industry solution. There's only SpaceX and Rocket Lab that fly AFTS systems in America. So. And it's a huge barrier. It's a massive, massive barrier. So if someone can develop a box that you can just go and put on your rocket, it just saves a tremendous amount of certification and time. And so what we're trying to do here is create something that's not just useful for Electron on Wallops. It's useful for any rocket on any federal range. And unfortunately, what that means is that requires a lot of certification for things that Electron doesn't even have. Electron is not air-launched, but there's a whole bunch of air-launch certification stuff to get done in there. So, we're really, trying to support the whole industry here and making sure that this the pain that we lived through with flight termination is not a pain that everybody else has to live through in the future, because I think it's a major gate. And as you're aware, our first flight was failed because of a flight termination system. Nothing to do with the launch vehicle. So we have a very strong interest in AFTS systems and making sure flight termination is a good element for the industry. But like I say, what that means is that it's just taken a long time to get all that certified for all of those different conditions and different ranges.
Gotcha. So the pad's ready to go though, and you guys are just waiting to finalize all the certifications for automatic flight termination.
Yeah. And it's it's unfortunately there's nothing that we can influence because it's NASA's software and NASA certification, so we can't. It's not like we can do anything there. But I'm certainly hoping that any of the launch providers in the future send me a box of wine or something for the delay we've taken for everybody in the future here.
I didn't realize that's what the reason was. And speaking of Wallops, you're also going to be, that's where Neutron's going to be flying out
Correct.
of. Is that exclusively? Are you only planning to fly Neutron from Wallops, or are you planning to fly it in New Zealand as well?
Yeah, so initially we'll fly it from 0A. There's a tremendous amount of infrastructure investment that's been created in that pad. And look, we know how to build launch pads very well, but it's always a very time-consuming and capital-intensive program. But this is one of the things that enables us to bring Neutron to market so quickly is the fact that we don't have to build all of that pad infrastructure. And Wallops is a wonderful site. We have great relationships with everybody there, and you can achieve a large amount of trajectories, including synchronous out of Wallops, which is really advantageous.
Yeah, you can do a little dog leg down there and still go. That's how big of that's got to be a fairly substantial payload penalty, though, especially if you're doing propulsive landing and
it's
a
actually
dog
not
leg
too
maneuver
bad.
from Wallops.
Yeah, it's actually not too bad.
Really?
I mean, it's better than the Cape, so it's not too bad at all.
Huh? Is that because the Cape you have to fly substantially far east and then do the dog
Correct.
leg? Do you just not have to go as far east? You can go more southerly.
Correct.
Right off the pad.
Yep.
Wow. So you are flying Neutron from Wallops. Where is Neutron planning to be built and manufactured then, wholly in the United States, or what's that actually look like?
Yeah, so Neutron is a relatively large diameter, and as we kind of clean sheeted the vehicle design, one of the constraints that I always thought was a little bit absurd is if you look at a lot of launch vehicles, they kind of fall within that 3.7 meter diameter, and that they're 3.7 meters because that's the lowest bridge between California and Florida. And constraining your launch vehicle to a piece of bridge infrastructure didn't make too much sense. So the obvious solution for that is to build it close to the launch site. So we're looking at all the different options around how one option, of course, very very close to the launch site, as in almost on the launch site, through to slightly further away where there's larger centres of infrastructure. But that was one constraint that we weren't going to have. Was that's a bad engineering constraint to have. From a vehicle design standpoint.
But as far as I feel like a new constraint used to, at least this mentality kind of used to exist, was you can't put a rocket factory out, at Wallops or, Kennedy Space Center directly, just because there wasn't as big of an industry built upon it. Obviously LA is kind of the home of so much aerospace. That's why traditionally it's been, that's why it's been used by so many aerospace industry people. But what's that actually look like then if you're building, out near Wallops or physically on Wallops ground, where are all these people going to be working, living, and I guess try to sell me on the people that are going to be building Neutron.
So I think you need to think about this a little bit differently, Tim, because this is a reusable launch vehicle. So it's not like we need to be building a whole bunch of stage ones, every flight. This is a completely different paradigm where we might only run a fleet of 4 vehicles and build one a year. So it's not kind of like this massive manufacturing machine that you may have thought about in the past. Of course, the challenge is that we need to produce a lot of them early on because no doubt as we're sticking landings we're going to have some issues. But once the vehicle's bedded in, then you don't have a huge manufacturing rate. Now the upper stage you do, because every launch vehicle that will be expendable for now. But I mean, definitely, focusing our efforts on that manufacturability. But your point is still a good one. And that's one of the things that is deeply in the trade is that. The advantage of building right by the launch site is kind of that, the minus for that is how do you get the people and infrastructure around you to be able to do that? And then, of course, the advantage of building in an area that is a large degree of population density and resources is, of course, that's not at the launch site. So, these aren't new problems for us. I mean, we already operate a launch site at Wallops, and of course, the Mahia Peninsula is probably the most remote place you could possibly imagine. But these are, of course, competing constraints.
Right. But the good thing is, I think if the pandemic kind of taught us anything, is I think there's a lot of people that are looking for a change in scenery. They're open to not living in a big city. I feel like there's going to be a lot of young talent and people out there that are looking for a change, and maybe something quiet like the ponies of Cinquetique or whatever they are.
Cinquetique, yeah.
That might just be charming enough for them to consider packing up and moving out there to develop that. So real quick, back to propulsive landing, because you talked about it and now I can't stop thinking about it. Mm-hmm. You guys, as far as I know, don't have any real experience with hovering or propulsive maneuvering, obviously other than in flight. Have you started tinkering around with any kind of models or anything like that, or any kind of hardware that's going to be teaching you kind of the algorithms and the practice of that, or are you looking to find a partner on something like that, like Maston or someone like that has a lot of experience with that?
Well, I think you need to acknowledge that it's broken up into two elements, right? One is control, and one is targeting. So control is control. Whether you're doing control on ascent or control on descent, you still have slosh. You still have all the external forces acting on the launch vehicle. You've got transonic regimes and supersonic regimes and hypersonic regimes that you need to control for. So the control issue, for us, we're not too daunted by that. I mean, we control a vehicle, Electron. Electron is like a Ferrari. If you want it to go left, it'll go left at like 0.1 degree gimbal. So it is a high performance machine. So as far as control of those kinds of things, the team, we're not too phased. The thing that probably we have less experience with is targeting, because it's one thing to obviously control a descent, but for us the more challenging thing is targeting and sticking something to within sort of 10 meters of where you want it to be. That's actually the greater challenge, and having the right kind of control authority to be able to target quickly is the bigger challenge. I mean, we see that with Electron reentry right now. I mean, we are through the manoeuvres we're able to get that down to pretty small impact ellipse for a stage one now, which is fundamental for us to be able to catch with a helicopter as well. Is actually we need to be able to target that impact point pretty accurately. But with Neutron it takes it to that one next level. So the areas that we're spending most of the time on, like I say, less about control, but more about making sure that we can target the landing point.
So what control systems are you going to have for aerodynamic control or reentry? Have you guys
it's
not
cool.
quite gotten
It's
that
cool.
far?
Oh no, this is all.
Yeah?
And then, when we do the next update, this is cool. You'll like this.
Oh, I'm really excited. I have just one more question, and still on Neutron, because I'm thinking about it. Is there any reason why you'd ever consider expending a Neutron, or are you just from day one just building in that this is a reusable launch vehicle and we will only fly it reusable? Or if a customer needs extra payload capacity, would you consider expending one? Or what are your thoughts on that?
Yeah, I mean, it would depend on the ability to build and the build rate, and an expendable Neutron is going to be pretty expensive, because if we're only looking at building relatively small numbers of stage ones a year, then to go and expend a fleet, I mean, I'd imagine it would be a similar question. Go to your local airliner and ask them if you could fly on a 747 and then just jump out on the way to Miami, and it's going to be a totally different ticket price, right? It's going to be a really expensive ticket. So we never say never. Learnt that the hard way, but certainly its intention is to be reusable. But if there was an expendable mission that justified the cost, then of course we would, we could look at doing that.
Well, now of course recovering a second stage is substantially more difficult than a first stage.
Yeah,
so is this something that you're not going to eat a hat over? You're never going to try and recover an upper stage?
I'm never saying never to anything ever again. This is clear. Let's be absolutely clear about this. But that is a totally different set of challenges on orbital upper stage. And at some point you have to, and you'll see with the architecture when we kind of show a little bit more leg on it, our approach here, because at some point that becomes more costly to try and re-enter and reuse than expendable. When you've got a large propulsion system, and a huge amount of capital tied up in all of that, it's a totally different kind of economic than upper stage with a relatively small or inexpensive propulsion system. It's completely different. If I look at Electron, the vast majority of all of the cost and the time of Electron goes into stage one, and the same will be said with Neutron. So our focus right now is to make really affordable, expendable upper stages, and coupling that with the architecture of stage one. We think we've got a way to make them incredibly cost effective and let stage one carry the majority of the work.
I can't wait to hear more about it then. And I understand you're going to be giving us a little bit of a sneak peek here in the near future for some of those extra details that you're just holding back on us right now. Is that correct?
Yeah, I think it'd be timely for another update, and we can like I say, we can give a little bit more view into the architecture, and I think that a lot of things will start to really make sense, I think, for a lot of folks at that point.
Well, the aerospace community is really excited. Obviously, this is something that we're all I'm so glad that you guys bring us along so well for the ride, too, and share what you guys are working on so openly. It makes it that much easier for us to all get excited. So I'm sure we'll be tuning in and paying attention very closely to whatever you do in the future. And, best of luck with flight number 20 for Electron. Let's hope it comes back here and looking even better.
Yeah, no, that'll be good. It's hard to believe number 20 as well. That's come around on us pretty quick. But yeah, no, it'll be a good flight.
Well, we're wishing you the best of luck, and we can't wait to see the pictures as soon as you get it back. I'm sure it'll be awesome.
Will do. Thanks, Tim.
All right, thanks, Peter. Have a good one.
Cheers. You too. Bye.